Okay, so what we're going to do in lesson 6.3 is we are going to keep the theme going with doing inequalities. If you remember, we finished up in 6.1 and 6.2 before the last test with solving and graphing our inequalities. Now, what we're going to do is we're going to be doing the exact same thing, but this word right here is different. Compound inequalities. There's two different types of inequalities that I could have. There's called an and inequality. X is greater than this and less than this, okay? So it's going to be, I've got a value that goes between these two numbers, or we have or inequality. X is either going to be bigger than this number or it's going to be smaller than this number, okay? So we're going to learn how to solve these. The and inequalities are first, okay? Anytime I have an and inequality, my x is always going to be in the middle of two signs. And that is exactly where I want it to be. I do not want that x to move to one side. It has to stay in between them. If it doesn't stay in between them, it changes what type of problem it is. And we're not doing that, okay? We're keeping it exactly where it is. So I just got to solve this problem exactly like I would, and I say, okay, x needs to stay in the middle, and I need to move everything that's in the middle to the outsides with it. So that means whatever I do to the middle of my problem, I've got to do to the front and to the back. So let's say, okay, I want to solve for x, so I need to add 8 first because I'm going to solve it just like a regular problem. That cancels out. But whatever I do to the middle, I've got to do to the front and to the back. Okay? So now I have 6 is less than or equal to 3x is less than or equal to 18. Now I want to get that x by itself. What would I do if I was solving a regular equation? I would divide by 3, which cancels out. Whatever I do to the middle, I've got to do to the front and to the back. Okay, so then I have 2 is less than or equal to x is less than or equal to 6. This is my compound inequality. Okay, this is exactly what I want my answer to look like. It has to be in the middle. And they want me to graph this inequality. Again, we're graphing it on a number line. And I know that x is going to fall between the numbers 2 and 6. Anytime you have an and inequality, I know I can do my number line from the smallest number, which is 2, in this problem, to the largest number, and it doesn't hurt to go a little bit larger, to the largest number, which is 6. I've got to be careful, though. I've got to look at, okay, what kind of circle do I need over the 2? Well, if it's less than or equal to, it has to be a closed-in circle. What kind of circle do I need over the 6? Less than or equal to, so it has to be a closed-in circle. And x can be any number between these two values. So I just shade in between the two dots. That's how you will always graph an and problem. Okay, so let's do this next one. What am I going to do to get x by itself? Well, first I need to move this 3, so I subtract it. Whatever I do to the middle, I've got to do to the front and the back. So I have negative 8 is less than or equal to 2x is less than 4. Now I divide by 2, because again, I want to get x by itself. Cancels out, and I get negative 4 is less than or equal to x is less than 2. Okay, I know I can graph this and inequality on this same number line. You never want to do it on two different number lines. Negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. Okay, what kind of circle am I going to have over the negative 4? Less than or equal to, so I know it's going to be a closed. And then over the 2, I'm going to have an open because it's just less than. And I'm going to shade everything in between because x is every number between negative 4 and positive 2. Okay? So let's do another one of these. 2 more of these. Okay? First of all, before I do anything, what's this number right here in front of x? Negative 1, so let's write it so we don't forget. Alright, I need to add 2 first. Whatever I do to the middle, I've got to do to the front and to the back. And I get 0. So negative 2 plus 2 is 0 is less than negative 1x is less than 3. Now what am I going to do? I'm going to divide by negative 1. What happens when I divide by a negative number? I have to flip my signs. So 0 divided by negative 1 is still 0, but it's going to change to become greater than. And then this cancels out in the middle, and I've got x. And then because I divided the other side by a negative number also, it changes to be greater than. And 3 divided by negative 1 is negative 3. So I know when I graph this, my values have to go from 0, oops, wrong way. You want to do smallest to biggest, don't forget that. And I'm going to have an open circle over the negative 3, because even though it's back there, it's still fine. Negative 3, and an open circle over the 0, and I just shade in between, because I know that x is going to be every number in between negative 3 and 0. Okay, let's do the next one. Add 1 to the front and the back. Negative 2 is less than negative 2x is less than or equal to 6. Now I'm going to divide by a negative number. When I divide by a negative number, negative 2 divided by negative 2 is positive 1. Flip my sign. This cancels out there, so I'm left with my x. Flip my sign again because I divided by a negative number. I get negative 3. So I know my values are going to be between negative 3 and positive 1. Okay, so I'm going to have an open circle over the 1, a closed circle over the negative 3, and I'm just going to shade in between them. Okay? So that's how we graph our inequalities that are called the and inequalities. X will always be in the middle. But then we have an or inequality. So I can say, okay, x is going to be either bigger than 2 or it's going to be smaller than negative 1. Okay, so anytime I have an inequality like that, it's actually very simple. All I do is I solve each of these like they are their own separate problem, but I graph them on the same number line. So it's kind of saving you some work. So I subtract 1 on both sides. 3x is less than 3. Divide by 3, and I get x is less than 1. Okay, so that's one of my answers. Now let's go ahead and solve this other one. So I add 5 to both sides. 2x is greater than 12. Divide by 2, and I get x is greater than 6. Okay, so these are my two answers here. You always want to write the word or in between them, so I know that x is either going to be less than 1 or greater than 6. So when I graph it on my number line, it has to have all of these numbers in it. So I'm going to do 0, 1, 2, 3, 4, 5, 6, 7. Okay? Graph it on the same number line. So I'm going to have an open circle over the 1, and x is less than. So I'm going to shade towards the numbers that are smaller than 1. And then x is greater than 0. So I put an open circle and shade towards the numbers that are bigger. Look at how my or inequality looks. They go opposite. Guess what? They will always go opposite. The and, when the x is in the middle and it's connected, the dots will always be connected. When I have two separate problems, there will be opposite, or the shading will go in opposite directions. It will always work out like that. Okay, so let's solve this last one. So I add 5 to both sides, and I get 6x is less than 12. Divide by 6, and I get x is less than 2. Solve this next one. 8x is greater than 24. Divide by 8, and x is greater than 3. So let's do our number line. 1, 2, 3, 4. Okay, x is less than 2, so no, it's an open circle. And I'm going to shade every number less than, and x is greater than 3. Open circle and shade every number that's less than 3. Okay, so that's how we graph our compound inequalities.